Hello class, welcome to the lesson of New Energy Vehicle Motor and Control System Maintenance. Today we are going to study the structure of permanent magnet synchronous motors. Everyone knows that the engine is the heart of traditional cars, but what is the heart of pure electric new energy vehicles? That's right, it's the motor. With the deteriorating natural environment and ecosystem actively exploring the development and application of new energy vehicles has become a focus in the field of automotive development. The rise of new energy electric vehicles. When discussing its power system, we often hear about permanent magnet synchronous motors and AC asynchronous motors. In terms of frequency, permanent magnet synchronous motors are commonly discussed subjects. What are the differences between them and what are their pros and cons? In this project, we will study together the performance, characteristics, and application of permanent magnet synchronous motors. So let's start by learning about the structure of permanent magnet synchronous motors today. Please take a look at the 3D animation of the permanent magnet synchronous motor to have an intuitive understanding of it. Think about the difference between it and AC asynchronous motors. The permanent magnet synchronous motor consists of front and rear covers, temperature sensors, resolver sensors, stator, rotor, and base. Now let's learn about them one by one. First, let's look at the stator. The stator consists of a stator core, stator windings, and base. The stator core is usually made of silicon steel sheets with a thickness of 0.35 to 0.5 millimeters, coated with insulating paint. The inner circumference of the core is filled with uniformly distributed slots for embedding the stator windings. The three-phase windings are embedded in the slots according to a certain winding method. The stator is installed in the base. You may notice that unlike AC asynchronous motors, there is no fan for cooling. Yes, permanent magnet synchronous motors mainly use water cooling. There are cooling water channels on the walls of the motor base, and the two cooling water pipe joints on the base are the inlet and outlet of the cooling water. This sensor is the temperature sensor, mainly used to detect the temperature of the stator. That's all for the stator part. Except for the difference in cooling method, the structure is the same as that of AC asynchronous motors. Next, let's learn about the second component, the rotor. The rotor consists of permanent magnets, rotor cores, shafts, bearings, and other components. Permanent magnets are mainly made of ferrite permanent magnet and NBFEB permanent magnets materials. The rotor core can be made of solid steel or laminated silicon steel sheets, depending on the pole structure. According to the position of the permanent magnets on the rotor, the pole structure of the permanent magnet synchronous motor can be divided into surface-mounted and interior. In the surface-mounted rotor structure, the permanent magnets are usually tile-shaped and located on the outer surface of the rotor core. The direction of the magnetic flux provided by the permanent magnets is radial. There are two types of surface-mounted structures, protruding and recessed. The interior permanent magnet is located inside the rotor and has better dynamic stability compared to the surface-mounted structure. It's widely used in permanent magnet synchronous motors that require a synchronous starting capability or high dynamic performance. The magnetization direction of the permanent magnets in the interior structure is different, so it can be further divided into radial, tangential, and hybrid types. As we know, an engine needs a crankshaft position sensor to detect the crankshaft's angle and rotate speed when it's rotating. What about the permanent magnet synchronous motor? It also has a component called a resolver sensor, which is used to detect the rotor's speed. It has 6 wires and 3 windings: the excitation winding, sinusoidal winding, and cosine winding. The control unit energizes the excitation winding, and when the rotor rotates, sinusoidal and cosine windings output 2 waveforms to detect the rotor's speed and position. Through today's study, let's summarize the differences between permanent magnet synchronous motors and AC asynchronous motors. The rotor of the permanent magnet synchronous motor is made of permanent magnet material, while the rotor of the AC asynchronous motor becomes magnetic after being energized. Another difference is the cooling method, with permanent magnet synchronous motors using water cooling and AC asynchronous motors using air cooling. Different motors and different structures result in different characteristics. I also hope that you can approach problems with a dialectical perspective in their future studies. That's all for today's lesson. Thanks for listening.